Seriously, thanks so much for having me. I'm really super thrilled to be back this year, to be able to talk to all of you guys. I do hope that we'll get a lot out of the presentation. I'm starting the timer now, 50 minutes. That will be tough. Feel free to switch on your phones and tweet and post about this and interrupt me at any time. I prefer that to waiting for questions until the end. I want to kick off this thing with the Our Giants of Email slide, and I usually try to do things a little differently in this regard. So for all of you ladies today who are here and comfortable to stand up, ruins my joke. Could you do this, please? Fab, you take the lead. Thank you. This was the most American thing I could find, by the way. It's a little mean, I don't mean it like that. Okay, now it works. So my name is Joerg, I'm an Austrian. I've been living in Germany for 17 years now, I think. I've been doing LabVIEW since 27. I founded the company Hampel Software Engineering around about 2015, 2016. We are the first NI Center of Excellence in Germany. I'm really very proud of that. And I do like working in teams. I like talking with people, talking to people. We used to do fixed price work in Europe exclusively, I think. And these days, nowadays, it's kind of drifting a little bit to also be T&M sometimes. I do like process and workflow standardization, automation, as it says here. And I do like open source and inner source. I guess most of you know that already. This is my 6th GDevCon, 4 times in Europe, 2 times here in North America. I'm also on the board of directors for the European event. So it is near and dear to my heart. One more reason I love being here with you guys. And it's a great event. So thanks to all the organizers. In my company, we like to create better software. Whatever that means, I would say. Usually what we do is we work together with our customers. We integrate with their teams. And we try to help them get the job done. Usually, our customers are engineers who are not computer scientists, so they need to use software. Not everybody of them enjoys it, really. So we try to make their lives easier. Today, we want to talk about DQMH Generic Networking Modules. First, I want to say that it's available today. It has been available for years. It's free and open source. So feel free to try it out. There's documentation available. There's the source code obviously available. We'll get into that later on. Can I get a quick show of hands who has tried out the generic networking modules? So it's oh, that's a lot. So I have roughly 115 people to advertise to today. That's good. What is the original problem statement? Originally, and this was way back before I used DQMH, probably before DQMH even existed with the previous framework that I had, the question was, well, we have distributed systems. How do I talk from my Windows PC to my target? And also the other way around, of course. If I have something on my target that needs information from the Windows PC, how do I do that? And this is where the whole idea comes from, where the whole concept comes from. So keep that in mind. And the agenda for this presentation, I learned that people like to know what I'm doing here. Introduction and code review was the original plan. That's not really the truth, I have to say. What I want is feedback on how I could improve the modules. This is what I am here for today. And I will have to talk a little bit about the concept and the basics before we can get into that. But seeing as we're all friends here, the total and complete and naked truth is what I want you is to try it out and then use DQMH. So we'll see how that goes. OK, back to the generic networking modules. We have to talk about DQMH modules, I think. We have to talk about networking, a little bit at least. And of course, I have to explain what I mean when I say generic, right? So let's start with that. So what is a DQMH module? Anybody wants to shout at me a definition? Anybody? Anybody? Fab? Come on.
I have been behaving all week, and now you force me to this.
You need to vent now, you know? Let it out.
So it is an independent module that can, well, it's a representation of an actor that can receive requests and decide whether it honors them or not. And then it can either reply directly to the request or can send a broadcast so the world can learn about it.
Reminds me of you, actually.
Oh, what?
That reminds me of you.
And it comes with a tester, so who would be my tester? Okay.
Okay, seriously. First of all, the DQMH module is a LabVIEW library. That library contains a bunch of VIs, and it has a certain structure. The next thing that a DQMH module is the main VI, right? So it is a VI. This is the VI that runs asynchronously. This is the place where things happen, I would say. And if you look at it from a computer science perspective, it is an actor. Not, of course, in the meaning of the actor framework, which I want to say is named not precisely enough, I would argue. It is the NI actor framework. But the actor as such is like a construct in computer science. And as it says here, it has state. It can send and receive messages. It decides what it does with messages. It decides when it sends messages. It has control over its own state. So all of these things make a DQMH module what it is. How does DQMH work? Very nicely, I would say. And it's quite rather convenient to work with DQMH because you have this tools menu with all these options that you can select from. So for example, you can choose to go to Tools, DQMH Consortium, DQMH Module, Add New DQMH Module. And what happens if you click the clicker from there, it doesn't work. It has a, is it 1 meter reach, Brian? I don't know, sorry. So what you get from the Tools menu entry is a nice little wizard. You need to type in the information that DQMH needs to create the module for you. You will give it a name, a location. You can edit the icon if you want to. Something happens when you do that, some wizardry behind the scenes, and what you end up with a DQMH module. So you can see here, it does have the LV-lib with those virtual folders and the main VI inside it. And it does have the API tester. Who is confident enough to say that they don't know what an API tester is? Everybody knows what an API tester is.
They're too afraid to raise their hands because Fab's sitting right
I'm
Okay.
not covering my eyes.
I mean, it makes me happy. At the same time, it's hard to believe, to be honest. The API tester is an external VI, external to the LV-lib, so you can use that to interact with your module the same way you would from your application when you use a module in an application. And the idea is to use that API tester to test the module while you're developing, or even while you're debugging. So once you integrate your module into your application, you can be rather sure that the module is okay. So if there are problems that you did not run into with the API tester, most probably it's within the integration with the rest of your system. So that's good. By the way, if you're working with DQMH, keep your API tester up to date. If Fab catches you and it's not maintained, good luck. Here's a disclaimer. Big disclaimer. Red, the exclamation marks. Screenshots shown on the following pages might not implement, adhere to, or even live up to the latest beta practices regarding readability. I have not been readabling. Sorry. If you want to learn more, there's this link. And I'm sorry if you don't see it in the back. I didn't have time to change slides. This thing has been created by a person called Mr. Darren Tiger, I think, from NI. I don't know him. OK. With that being said, here's the first screenshot. So what does a DQMH module look like? It's a lot, I know. There's a lot of boilerplate code. It takes up the whole screen here. There is stuff to boot up the module. There's stuff in the middle where things are happening. Then there's stuff to the right-hand side when we need to shut down and tidy up everything. But it's, all of this is scripted, first of all. So this is a vanilla module that you look at. So you didn't have to create any of that code, which is good. And basically, it's just a simple producer-consumer pattern. That's a design pattern where you have one place that produces, I will say, messages, and another place that consumes those messages and acts on them to keep the producer responsive while the consumer might be working on something that takes a little longer. Now, in the NI world, we add a queue to that pattern, and we have the queued message handler. That's a pattern that probably most of you are familiar with. It's been around for a long time. And if you hear me say that this is the queued message handler, the QMH, and the tool we are talking about today is the DQMH, kind of gives away that the DQMH is built on that pattern. We do have the event handling loop on top of the module, so this is the place where events are caught and acted upon. And then we have the queue, and we have the message handling loop in the bottom. And this is the place where the actions are actually executed. And I do that by using the public API of the module. So the public API is a bunch of VIs that you create. Those are public within the library. So these are the VIs that the users of this module are supposed to put into their code to interact with the module, to tell it to do something. But what it does happens down here in the message handling loop. So why should you even bother creating a module? What is the benefit of having a module? I'll give you 2 reasons, and then we'll see if there are more. The first one is modularity. A module gives you modularity. I mean, that's not so surprising. You can see here a power supply, or maybe a database where we have some VIs that we use to do stuff to it. So we want to read a config file. We want to connect to the power supply, set the voltage, read the current. These are all public API VIs, so they're using an event behind the scenes to go to the event handling loop. The event handling loop will receive the message, will forward it to the message handling loop, and the message handling loop is the place where it will actually use the power supply driver to talk to the device. So now you might say, well, that's not so thrilling, to be honest. I could do an FGV or an action engine. I could do a class. I could do any other thing in the world. And you're right, I'll give you that. From the point of view of just doing the actions, you could do that. What is another reason, then, to have a DQMH module? I will say parallel processes. So if you want something to be in memory and act and happen and work while you're doing other stuff, that's a bit slightly more difficult with creating from scratch. And this is where the DQMH module is quite helpful, because you can add another loop to it, a helper loop. So you can see here the third loop. And this third loop could be, for example, a data acquisition loop. So you have the event structure inside, you have the timeout, you can set that to some value you like, and you can make it do things repeatedly or iteratively. In this case, for example, there's a hardware abstraction layer that we use to acquire data from some device and do that continuously, so we have our data acquisition. So that's quite handy. Anybody knows of any other reasons? Just very briefly, is anything else that comes to mind why you should use a framework, an agreed upon architecture in your team? Obviously, that might be a reason. You want to standardize on one way of doing things, and using a certain architecture helps a lot with that. Doesn't have to be DQMH, of course, necessarily. It can be anything. But it helps a lot with working in teams to standardize on one pattern for all the reasons that we have. OK. Next up, networking. I do hope to have more luck with this thing than Brian had yesterday. Could you please try and go to this page, menti.com? Perhaps the QR code even works, ideally. Then type in the number. Can anybody confirm that this works? I'll give you a few seconds. Jeremy's arm is too short. I mean, he could have gotten up. OK, 16 responses. Something must be working. Interesting. So this is what you think about when you think about networking. Blah. There's 2 blahs, actually. Come on, people. Brian, was it you?
It just says enter a word.
Oh, so I screwed up, is what you're saying? Yeah. Of course I did. So what I was after, actually, was to have you guys enter things that you think about when thinking about networking. Didn't do a good job, obviously. And it's too late to save the day now. Doesn't matter, really. Let's see if we can turn the ship around. So could you now enter something that's related to networking, maybe, and see how that goes? Let's see. Communication, I see that. TCP, I see. Fun, not sure if that's related to networking or not.
It does say here, please, for the sake of my presentation, think about computers not hooking up. And then it says networking. So, I'm just saying.
If you're reading precisely like Fab does? Yeah, it was too small. Anyhow, the idea of this was not to gather a lot of information. The idea was to show that networking is a very broad topic. You have protocols, you have architectures, you have all sorts of things that you can talk about when you're talking about networking. And the generic networking modules can't cater to all of that. That's basically the point I wanted to make. So going back to the slides, network architectures are one of the things that might be interesting to just think a little bit about very quickly. There's client-server versus peer-to-peer. There's publish-subscribe versus request and reply, connection-oriented or connection-less, unidirectional, bidirectional, message versus stream, one-to-one, one-to-many. So, of course, depending on the needs or the requirements of your system, you need to pick a different architecture for your network. You need to sign it differently. Maybe you want to use plain TCP or UDP because that's good enough, which it is a lot of times for me, and Darren at least seems to agree to that. Maybe you want to hook into something else like, I don't know, MQTT, gRPC, all these abbreviations, all these protocols and technologies. Depending on what your needs are, the DQMH generic networking modules might or might not be a good fit because they were designed with TCP client-server scenario in mind. We'll see that later on. So I've worked on creating an abstraction layer for that network communication. But I only could take it so far. So it's still, if you look at it from a bird's view, it still like has the elements of a client-server architecture. So if you want to shoehorn in something else, that might be tricky. But there is a starting point for that. So it's possible, I think, technically for most of the scenarios. OK, let's talk about a generic. What could that mean? A generic networking feature, to me, or what I had in mind when I created it many years ago, it should be built right into the framework. So it should be a native citizen of the framework. It should be simple to leverage for the developer, potentially even be configurable. And ideally, I wanted it to be transparent to the user. So what do I mean by that? The DQMH GenNet should work with any custom-made DQMH modules, so also your projects, not only mine. Which was challenging, of course. I wanted to use the module's public API, no matter where the actual code is being executed. I wanted the convenience of the public APIs to be used in my application. And I needed to support runtime configuration, meaning I needed to switch at runtime between local or remote mode, if you want to call it like that, or maybe switching from one target to the next, if you have like a bunch of real-time systems, for example, you want to connect to. So these were the requirements that I had. And if we look now at the architecture, what I needed to do basically was to cut the module in half and like have part of it running locally and part of it running remotely. Specifically, I wanted to use the public API, as I said, on one system, which goes into the event handling loop. But then I wanted the message handling loop to be executed on a different system. So my idea was to cut the queue, if you will, and see how I can make it so I can reroute the messages in that place. And I did that through the help of helper modules, for lack of a better word. So I created two modules, a client module and a server module. And those modules are basically like private instances of the calling module. So when we tell the calling module to start the network service, it will start the client module or the server module, depending on which side you are. It will share some private resources so they can communicate with each other. And the helper modules, they should take care of doing the actual network communication. So we're doing good. I still have half an hour. Let's look into the implementation now. What do you need if you want to use it? Again, it's available already. There is documentation. There is the source code. Documentation is on our Doku wiki. I will share the links again and again. The source code currently you can get from our repository on our GitLab server. It is a self-contained repository with all our reuse libraries that you need for that. So you can see a screenshot of our GenNet support functions that we have there. We are currently in the middle of migrating our reuse codes from a repository to VI-lib, amongst other things to make it easier to have templates for these kinds of things. And I did not find the time to update the GenNet project before the conference, which was the plan. So right now, if you wanted to try it out tomorrow in the morning, you would have to go to the repo, clone the code, and work from there. In the future, it will be easier for us to provide templates that you can use, as you usually do in the DQMH world if you want to create a module from a certain place. OK, so with that being said, when you clone the repo, it works just right out of the box. So you can do that, and then you can take it from there. But I do realize, I do understand that it is not super easy and super straightforward and super trivial to do that. And that's also the feedback that I got from the few people who have been using it. And that's also one of the reasons I'm here, because the idea of this presentation is to get some feedback on what could be made simpler or easier, or how could we make it more accessible to the rest of the community. I mean, that's the reason for it being an open source project in the first place. OK, so how do you make your existing DQMH module GenNet enabled? The first thing we implemented and you need to do is override the message queue. So we see the message queue, that's the purple wire in that case. We see the mouse? Yeah, perfect. So we see this wire, it's not light blue anymore, so this is already the overridden child implementation of the message queue. So there's the VI that creates the message queue object. And thankfully, thanks to Fab, the message queue is wrapped inside a class, which allows me to do these things. So I can manipulate the queue in any way I see fit. And what we did was, and you'll see it in a second, override the queue so we can have the rerouting for the network. But you could do all sorts of things. You could even do away with the queue and implement something else, like a JKI state machine kind of thing where you use strings, for example. If that was helpful for any reason, you could do that as well. So this is one of the places where DQMH actually uses and leverages and benefits from object orientation, even if you don't need it if you're working with the public API. So anyhow, the VI that dequeues the messages, so the VI that sits at the beginning of the message handling loop waiting for incoming messages, this is where the most important change was done, I would say. So the VI sits there, it dequeues a message, and then we have a new property in the object, which is send via network. And if send via network is true, well, and the message is not blacklisted, we will reroute the message, and we will not send it to the message handling loop case that it was designed or meant to be sent to, but we will move it to send via network, which is a different message handling loop case. And that message handling loop case contains the function to forward it to wherever, to send it through the network. So this is actually super simple, I think. I was very happy when I thought of that, because this was the easy part of all of it. And that works like a charm. You switch it on, it goes to a different case, whatever it is, it's sent via the network, and Bob's your uncle. OK, so that was the easy part. We're ramping up now. Well, not yet. What else do you need? You need functions to switch your networking on. So of course, you need to add that to your module. You want a public API request where you can say, start forwarding through a network. Of course, there's a sub-VI. We'll look into that later on. That sub-VI will take care of starting that helper module, sharing the resources, and doing these things. But what you need to do to your module is add a request or add a place where you can enable the networking. Let's put it like that. It doesn't have to be a request, actually. It can be only in the messaging loop. Of course, the same thing holds true for the server side. So if you want to start receiving messages through the network, you will have to start that as well. So you need a place in your module where you say start the GenNet server so it can start listening on the network. receiving messages and processing those messages. So far, all is well. That's not too bad, I want to say. The one thing that's not so handy is that we need to augment each request that we want to be networkable, following Darren's lead here. So there's a bunch of things we need to do because the request and wait for reply, which is the synchronous message in the DQMH framework, has an event to talk to the module, and then it has a notifier reference for sending the answer back. And that notifier reference can have any data type that you design it to have. So if you want to send back an array of something, the notifier is of that type, right? So that's not so bad, but the problem that I ran into is that the notifier reference is part of the payload of the message. So every message has a different data type. And I know what you want to say, Alan, I guess. What if the message was a class? Yes, that would make things easier. It's not, so that's what it is. So what we need to do to make it so we can take any message, regardless of the data type, we need to change something. We need to change something that's part of the framework code. And at the same time, it's part of the user code that you create because it's part of that one event that you created. That's where one of the bottlenecks of this design, I think, sits, but I couldn't find any other way to do it. So anyhow, long story short, what we need to do is we need to change the way that the notifier is handed forward. And the data type of the message queue that is being used to send messages down is a variant, right? And that variant is of a certain, the variant contains a certain data type depending on the message. So what I did was, instead of having the wait notifier being part of the cluster inside the variant, it is now an attribute of the variant, which allows me to use it in a generic way. The next thing we need to do is, of course, on the other end. So when we unwrap it, we need to get the notifier reference out of that variant again. It's not in the unbundle function anymore. So usually you would have it here in this unbundle because it is part of the data of the variant. I changed it to be an attribute of the variant. So I need to get the notifier reference in a different way. And then, of course, when we send the reply, we need to make it a variant again because the data type of the notifier is also a variant so that it can be generic, right? So that's not good, I would say. I don't like it a lot. You don't need to do it all the time. That's the other argument. But still, this is a hassle. So this is potentially something I'd be interested to hear how the experience of those people who used it was so far. Was that a problem? Or do you say, well, you know what, once I figured out what I need to do, I just did it and it was fine. It doesn't stop here, sadly. Next thing we need to do is, of course, going backwards, this is the module that receives the request from the public API VI, right? So this is the incoming place. The notifier is already of data type variant. It's already generic at this point, which does mean, sadly, that we needed to do something to make it that. So the next thing we need to do is in the request VI. Hope people in the back can still see it. We need to change the notifier reference to be of type variant. Okay? That's the fourth manual action you need to do. And then, of course, when we're sending data back, when it's arriving at the place where it originated from, that's the fifth place. We need to now use the variant to data node to actually convert it back to the data type that it was meant to be originally. So that's a lot, right? So you think about your public API, you have the public API VI, and you want it to be synchronous. So you're sending a notifier reference together with the payload. Okay. You need to change the notifier from being strictly typed to being a variant containing something. You need to change the place in the module where you receive that message. You need to change the places where you're sending data from the event handling loop to the message handling loop. And you need to change the handling of the notifier reference in the message handling loop. That's a lot. Again, I will acknowledge that I don't like it. But also, again, I didn't find a better way to do it, and it was necessary so I could make both points, both sides, generic. So that's what I have. That's what we have right now. OK, let's look at the supporting elements here. We have the helper modules on both sides. So we have the client module, which forwards messages over the network. And we have the server module, which receives messages from the network. And then we have the transport layer, if you will, the communication part. So I created a communication abstraction layer. And for historical reasons, I want to say, because I didn't know better, I called it a protocol. So GenNet supports multiple protocols, you could argue. The protocol being both the transport mechanism and the format of the data being sent. So it's a little bit of a mix-up. Probably we don't have to care too much. I just want to point out that this is what GenNet means when we talk about the protocol here. And we have two versions or two variants, two variations implemented. One is the variant protocol, and the other one is the plain string protocol. Now, the variant is the one that was there from the very beginning. It's just taking the message variant, the variant that contains the message, flattening it to string and sending it over the network via TCP/IP, straightforward. And then we do have the plain string protocol, which works slightly different. It takes the message data and makes a string, a human-readable string out of that. And that is because one of our customers wanted to be able to talk to the application also from MATLAB. And MATLAB did have a hard time creating the LabVIEW data structure. So we decided, well, a plain simple string, that would be nice to do. So we implemented that as well. And that was the first time that I thought about the abstraction layer for the communication, for the protocol. And just to illustrate, not really to discuss, we have a VI on the server side that waits for incoming connections. So there's a VI that is called wait for connection. For this example here, for the variant protocol, it is a TCP listener, and we wait for a connection to be made. If a connection is made, we spawn a new connection object, and that takes care of the rest of the communication. And then if you look at the communication VIs, write message and read message, they are very straightforward. There's nothing fancy in it. For writing, we take the variant, we flatten it to a string, we prepend the size, and we send it through TCP, just like that. And on the receiving side, I thought it would be just as easy. It turned out not to be just as easy. We receive something over TCP. The first 4 bytes contain the length. We read the remainder of the message. And then we just convert it back to a variant, right? So who knows what I ran into? Who can guess what I ran into? Thankfully, the VI icon is not legible in the bottom, so you can't guess from that. So what can go wrong when you're sending a variant over network to another application? No educated guesses?
If there was a hold on. No, I was working actually.
I would be concerned of end of line or carriage return line feed causing the network to think the message had already been transmitted in its entirety when it hadn't been.
That's a very good guess. That's another thing where I fell on my face and didn't know what to do because I couldn't figure out about the different operating systems. But not in this case, because the flattening to string for the variant, that seems not to bother with end-of-line characters. So yes, that's a huge problem that I also ran into, but it was not that problem. Any other educated guesses?
I guess, would you be, enforcing the type because you don't know what you're getting?
So I don't need to do that at this point because it's a variant. So that's the way that I did it was I only need to know that it's a variant. I don't care what is inside at that point when I'm receiving the message. So the output of that VI is still of type variant, and variant is variant. So that's OK. Anybody who has, oh, sorry.
Maybe I'll make a guess. Could it be an endianness problem?
Sorry?
An endian problem?
Not that one, no. Not in that situation, at least. So who has dabbled with variants and looked at how the data format of a variant actually looks like, what it comprises?
So that I was going to say, if it could be incomplete and not get all the information from the variant?
Well,
Because you have to actually tell it that you have to give it information on the other side in order to decompose it into whatever is it that you need to do.
well, I don't decompose it yet.
No,
So
but,
that-
but the variant itself doesn't have all the information, right? Because of the format of the variant.
Well, it doesn't need it at that point. So that problem would also occur later on. So, okay, we have 50 minutes left. We can play that game longer, but I won't. The thing with the variant is that for whatever reason, and actually some of the ANI guys should actually know the answer now that I think of it, because you guys created it. I guess it was Mr. Tiger? Okay. So, rah. Mr. Tiger got it. A variant contains the LabVIEW version that you saved it in. So if you want to like convert it back, that will fail if you do it in a different LabVIEW version. So if you're sending your message from like a 2020 application to a 24 application, that will actually fail. And you can imagine that like young Joerg, when he did that, did not know anything about that and scratched his head quite a lot. It's not the reason for my hairdo, but could be. So it contributed probably. It contributed to the gray, to the blonde hair I have here. So that was really difficult for me to figure out. So if you convert a variant to something on one LabVIEW version, and you want to like unpack it in another version, you need to take care of those, I don't know, third and fourth byte or whatever it is, because that contains the LabVIEW version. So inside that little VI on the bottom, this one here, what I do is if I get a certain error, 15 something, I will have a variant constant in that LabVIEW version, cut the first 4 bytes and overwrite the other ones, and then it works again. But yeah, boy, that was a tricky one to figure out. And it's only a TCP thing, right? So you think, what could go wrong? Okay, for the helper modules, the GenNet server, it does nothing fancy, really. You can see on the screenshot, there is a helper loop for the server that is spun up because it wants to listen actively for incoming messages. And there is this protocol wire here where we have the methods, and this one is like listening for incoming messages, and if something comes in, we create the object for the connection itself. We will spawn a separate service running in parallel that will take care of that one client, and we'll go back to listening if there's another connection. So it supports multiple clients. If you want to start that helper module from our actual module that we want to use, this is quite straightforward. So we have the usual code for starting a DQMH module, plus the start module VI also takes the protocol object as an input. And for the variant protocol, we just need the port number. That's everything you need. Because it's only, again, a simple TCP connection. If you wanted to implement something else, this would be the place to provide additional parameters like, I don't know, the protofile for your gRPC or whatever it is that is needed by your application. So I guess that's nice, that's straightforward. I'm okay with that. Also, like the helper modules, usually you don't need to look into that code. We've been using that for quite a few years now, and there's nothing to do in there usually. With the addition of the abstraction layer, that might change in the future, but I'm not too concerned about that part. So one interesting thing I want to point out here is that we do share the message queue object with the helper module. So that might be a red flag. Who has an opinion on that? Any opinions? No opinionated people? Wow. Well, it's sad because it would have contributed to my presentation, but I can do it for you. The thing is that the message queue of a DQMH module is designed to be a private resource. That's one of the basic ideas of the template, really, to say we have something that has the events, the public API coming from the outside, and then we have our message queue connecting the event handling loop to the message handling loop, and I have complete and total control over who adds messages to that queue. It's a private resource. I don't need to worry about like anybody injecting messages in a way that I don't want to. I could implement in my event handling loop something that actually discards messages in certain scenarios for certain periods or whatever. So Delacor and Fab made a point of having the queue be a private resource, period. So how do I dare share the message queue now with the helper module? I will argue that the helper module is also a private resource of that module. You do not have access to that helper module from anywhere. It's spun up programmatically under the hood. The user will never see it. So I feel like it's okay to share the message queue because it makes my
This lobby doesn't let you have a library that goes cross targets.
yeah.
If you could have a library that has components in the
So Lavio doesn't let you have a library that crosses targets. If you could have a library that some of the VIs are on the my computer target and some of the other VIs are on the network target, then you would have.
I mean, yes, and what I really wanted to do, you can kind of see it. What I wanted to do was like cut the message queue in half and somehow like beam the message from the event handling loop of one place to the message handling loop of the other place. So it just does make sense, in my opinion, to share the message queue, because what we can do is we can forward it here, and then the GenNet server, when the GenNet server receives a message, it will just inject it directly into the message queue of the module, which is convenient. So, GenNet server, the way you started. GenNet client, same story really. It has no helper loop because it's like being triggered actively, of course, for each message that you want to send. When we send a message, when we spin up the protocol, it needs a little more information. It needs the IP address and the port number and the timeout. And also, we don't only share the message queue, we also share one of the broadcasts, which is a generic broadcast in our HSE templates. So the helper module can also receive broadcasts over the network and distribute them to the module. And the module can then forward those broadcasts as if they were created on that side of the system. So, seeing as we have 8:15. Okay, seeing as we have some time left, I'm surprised that we do actually, first of all. I'm wondering, can I get some feedback maybe from the people who have already tried the modules out? Is anybody willing to speak to that? Perhaps, Jeff.
What do you want to know?
After hearing like the last 35 minutes, is anything that I forgot to mention or that I missed out, or should I have talked about something else?
Well, there's just, a couple things he and I talked about when he first got here, because I talked to him about using this, and I use it in the implementation I use it in is I have a PC, I have an RT, but the RT is also standalone where I have a touch screen to control the RT, so it's like a piece of test equipment. So I had to do dual mode at the same time. So using the network, when I downloaded it and tried it the first time and failed for like the first 2 or 3 days because I was having some challenges, partly due to directory structure, which I know you're working on taking care of with the VIPM. But once I got that running, it was pretty straightforward. I guess the only thing I hate, but there's really not much we can do about it, is the amount of steps, because you have to do the client side, server side, and you have a few more steps in the middle. If you're familiar with DQMH and how you're making all your broadcasts and requests, you have to do a couple more steps in the middle, but once you figure that out, it's cake.
Would you want it to be scripted?
Maybe, but I've only used it in one design application. I have about 2 or 3 others that I need to do it with, so it may change. So the scripting may be great, but you may have to do, well, if I'm doing this, I'm doing it, But outside of that, I really like it.
Thank you, Jeff.
So I haven't used it, so it's no feedback on that.
Okay.
But it reminds me of a thing I set up, and I was wondering if you thought about using something like or similar to JSON RPC over 0MQ. So 0MQ to your networking stuff, and send JSON instead of those variants. There are good packages to do the serialization. So did you think about that?
I did think about it. We haven't had any reason to actually go to the extra length of implementing that for this particular template here. I talked to a few people, Mr. Tiger amongst them, and we do agree that the plain, simple TCP thing is good enough for many of our use cases. Lots of our test systems are not connected to the internet. They are in an isolated machine network maybe, and I feel very at home with the TCP functions. So personally, it's okay.
That's fair enough for the networking stuff. And about JSON?
Again, there was not a need to do that. The one thing that I'm interested in trying out in the near future is to see how I can make it work with gRPC, because this is something that we do a lot of work with recently for some of our customers. And I haven't had time to try that out. And I do appreciate that there sometimes is a need for a more secure or more managed or a more convenient network layer below these modules. And I think I've taken the first steps in creating the abstraction layer, but I haven't really had time to try it out, and nobody has sent us a purchase order to do that. So it's still on the list to do. So yes, I've been thinking about it.
Okay, thanks.
Yeah. Thanks, Stefan. Dan. Faster, faster, faster.
Still early.
Oh, come on. It's 5 in the evening in Germany.
Is this on? Yes. Hi, Joerg. Thank you so much. A couple of questions. On the client side, what happens if the server goes offline and comes back? Do you have a provision for reconnect?
Yes, there is. The next time you want to send a message, or every time you send a message on the implementation of sending a message on the client side, it will first look if the parameters are correct. Is there an IP address? Is there a port number? Are they not empty? And then it will check the network connection. And if it's not valid anymore, and I think it's just seeing if the reference is valid, or if there was an error the last time sending, that's on the shift register, then it will reconnect, or try to reconnect at least.
Okay, so it'll continuously try, or just when it
once.
has the next thing?
I think just once for
Okay.
each message, if I remember correctly.
Okay. So, all right, next question is, when you make
Sorry,
one
Dan,
of these...
sorry.
Yes?
Actually, it is once, so you need to keep trying to send a message from your application.
Okay.
So it's once, yeah.
So it needs to be aware that the connection dropped and then start reattempting with using some external request. Okay. So when you implement this, is it one DQMH module running in 2 different places, or is it 2 distinct modules, one client, one server?
Very good question. I didn't think I could shoehorn this in. When I started this whole thing, it was one dedicated module. So think about a database that is accessible only through Windows, because it only has Windows drivers. But we need to use it from our PXI system. So what we did was we created one module that contains all the functions, and then we added the generic networking. So on the real-time system, I would still use the same public API VIs and say connect and query and whatnot. But the actual execution would happen on the Windows system, and that would be the exact same source code. Which sounds nice, but of course now you have the Windows drivers in your real-time project if you don't have any kind of abstraction or whatever. So at the very least thing you would need in that case would be a diagram disable structure. Okay, still works. Over the years, we figured out that it can be handy to not change your module to be GenNet enabled, like with the purple Q wire and with doing everything under the hood, but just use the helper modules and start them manually. And then you can just have one function in your module that is very specific to your use case, and it could be maybe the endpoint on one of the 2 systems. So what we ended up doing a lot was to have a GenNet enabled module on one side, and the other side would just be implementing the messaging side and would not be the same exact source code to avoid bringing in all the dependencies. So having the network layer is still very convenient because it just works out of the box, and you can implement it manually. So one side, you would have to do the converting from variant to data, again, manually, statically in a block diagram. The other side, it would just have all the cases on your PXI system to say, talk to this thing or talk to that device or whatever, and could have all the dependencies in the world because it would be the RT module.
Cool. Thank you.
48 seconds. We have time to shoehorn one more question in, I think. Come on. Make it count, people. No more questions? Okay, so I have a question. Oh, wait. Hey, Norm.
because you're okay with just using TCP as is and not trying to go through the other aspects of it, did you contemplate just leveraging VI Server instead of doing a bunch of flattening and just opening up app contexts on different systems instead of having to do all the flattening and all the other hoo-ha to make that happen over TCP?
I actually did not, because I never tried it out. It never happened to me, so it was never on my radar. And like I said, I'm very confident. I'm very comfortable with TCP. Plus, I have all the VIs that do the reconnect, etc., sitting there, so I have no pain.
I did have a customer that was not running that. That's really
Yeah. For one of the sites, it is convenient to have something else do that. I was burned by network streams a long time ago, so I try not to use, what do you call that, proprietary NI technology for networking. Okay.
Thanks, Joerg.
Thank you so much. Have a great last day.